Hey, it's Mr. Shrum, and welcome back to a physiology lecture walkthrough tutorial. And today we're going to look at the musculoskeletal system. And we will see how muscles and bones work in tandem. They work together to allow us to move, and it also protects our vital organs. So here we see the several functions of the skeletal system. That's a skeleton, obviously. It allows us to move. It supports the entire body. It gives us structure. It also protects organs like the brain, the heart, and your lungs. It produces blood cells, red and white blood cells, and stores minerals as well. So here you see a bit of this structure of bone. It's a rigid organ made from calcium salts. They serve as anchoring attachments for most skeletal muscles. And that means when a muscle contracts, it pulls the attached bone and the body is able to move. It supports the entire body. And if you didn't have bones, you would be this slug-like creature where you're just all bendy and you don't have a lot of hard structure, hard lines. It's kind of like if you guys ever seen Harry Potter when he loses a bone and his hand's all floppy, it would be like that. It gives us some structure and it also helps organs and tissues. The skull protects the brain. Your rib cage protects your heart and lungs. You don't want those organs to be damaged. So without bone, they would be very vulnerable. But bone helps protect those organs. And during adulthood, within the hollow core, that is called the marrow of certain bones, white blood cells, red blood cells, and platelets are produced. And here you see that. And okay, this is a fun word. See if you guys can say it on the first try. This production of blood cells and platelets is called hematopoiesis. Hematopoiesis. And if you want to hear the person say it, if you read aloud, here you go. I think you guys can hear that. Maybe? Okay. Yeah, read aloud.
Hematopoiesis occurs in red bone marrow. A small
Okay. Hematopoiesis. It's a weird word with a lot of vowels, but this occurs in red bone marrow. And a small amount of adipose tissue, that's a fancy word for body fat, is stored in bone as yellow bone marrow. So you have red bone marrow where blood cells and platelets are produced, and then you have this fatty yellow bone marrow as well. Bones are composed mainly of calcium and phosphorus and act as mineral storage deposits. Minerals give bones its rigidity. It makes it hard. In addition to calcium and phosphorus, these minerals are also stored in bone. Magnesium and sodium salts, those are also stored there. These minerals are essential to bone and other body processes like blood clotting, muscle contraction, ATP synthesis. And if dietary intake of these minerals is insufficient, minerals may be withdrawn from bone until they can be replaced when your diet improves. For example, rickets may develop in a child that is deficient in calcium, phosphorus, or vitamin D. Rickets can occur in children ages 6 months to 24 months, so between half a year and 2 years old. And that happens if they don't get enough vitamin D. So their bones fail to mineralize. Vitamin D is really necessary for the absorption of calcium and phosphorus. And without those essential nutrients, bones become soft and weak. And weak and soft bones are not useful for us. bone is not a solid material. Rather, it's made up of differing tissues with spaces in between. And the tissues that form bone include periosteum, compact bone, and spongy bone. Now the periosteum, let's get a read aloud there.
Periosteum covers the outer surface of a
Periosteum. Think of osteoporosis. Oste is a root word for bone. So anytime you see something osteum, osteo, think of bone as a root word. And the periosteum covers the outer surface of a bone and provides the bone with blood and a supply of nerves. You can see that there. Compact bone is hard, the hard outer layer of bone, and it gives it that smooth, whitish appearance. Compact bone is also referred to as cortical bone or dense bone. And that accounts for 80% of the total mass of the skeleton. So you can see how the periosteum is on the outside, but then you have this layer going all around the bone of compact bone. And then within that is spongy bone. That fills the inside of bone, and it looks kind of like a honeycomb. There's a lot of holes, and the network allows room for blood vessels and bone marrow to move through. Spongy bone is also referred to as cancellous bone or trabecular bone, but we like to stick with spongy bone here. Two bones meet together at a joint. So think of your elbow joint, your knee joint, your shoulder joint. They are joining together. And the functional classification determines how much the bones are able to move. So depending on how much you're able to move your body in a certain joint is how we classify it functionally. Structurally is determined by how the bones are actually connected to one another. And there are two main considerations: whether there is a joint cavity or not, what kind of supportive connective tissue surrounds the joint. And there are three functional classes of joints. We have the cyanoarthrotic joints, the amphiarthrotic joints, and diarthrotic joints. And what that means, cyanoarthrotic joints are immovable joints. So think of sutures. Sutures on the skull are the joining of these parts of your skull. So see how there's divisions in your skull. Those joints, you can't move those. So they do connect bones together, but they're not joints the way we usually think of joints. Then you have amphiarthrotic joints. They can move a little bit. Think of the discs between your vertebrae, the vertebrae of your spine. That is a joint that you can move a little bit, but not as much as other joints. Then you have diarthrotic joints, and those are freely movable joints. They allow your body to move in various ways. So think of the hip joint, knee joint, elbow joint, all those joints. Those were the functional ways to classify your joints. Now there are three structural classes. You have fibrous, cartilaginous, and then synovial. Fibrous joints are characterized by the absence of a joint cavity and the presence of fibrous connective tissue surrounding the articulating bones. So Sutures in your skull, another good example of fibrous joints. Then we have cartilaginous joints are characterized by the absence of a joint cavity and the presence of cartilage. Cartilage binds the bones together. So an example of that would be the pubic symphysis. That is a cartilaginous joint. Then we have a synovial joint. They are characterized by the presence of a joint cavity and the presence of ligaments that provide support for the articulating bones. A ligament is connective tissue that connects a bone to another bone. The two types of classifications are correlated with one another, and most fibrous joints are cyanoarthrotic joints. Most cartilaginous joints are amphiarthrotic joints, and most synovial joints are diarthrotic joints. So cartilage, ligaments for synovial, and the most movable joints are usually diarthrotic and synovial. So back to the functions of the skeletal system. It has several important functions. It enables the body to move, supports the body, protects the organs, produces blood cells, and stores minerals. And the articulations or joints are where two bones join, they meet together, and we classify them in these two ways, functionally and structurally, and they usually go hand in hand. Cyanoarthrotic, immovable, usually joined by fibrous connective tissue. Amphiarthrotic joints, slightly movable. They have no joint cavity, but they do have cartilage. And then you have diarthrotic joints. They are freely movable. There's a joint cavity present, and ligaments make it a synovial joint. All right, so that is the first lesson, and we will stop there, and we'll get back to the musculoskeletal system next time. But until I see you again, have a good one and stay safe.